Hello, friends. Welcome back to our sessions and discussion about the sensitive ground fault detection. We have discussed more about what the type is, the directional, non-directional, and whatever the basics were required in the previous sessions. We discussed around 8 sessions about the three. I state the first method, about 6 sessions on the second method, and 4 sessions we discussed about the third method, and right now we are discussing about the fourth method of detecting the fault, ground fault, by the method of using the Corballin's transformer, means sensitive ground fault. In the directional, with the admittance stage with B0 and with G0, it means susceptance or the conductance and the susceptance method by measuring of these two values. Before starting the discussion on the functional block diagram, let's understand about the basics of Y0, G0, and B0. From the basics, we know that if we have the impedance of the system, Z is equal to R plus JX, that R is resistance part and the X is the reactance part, and Z is the impedance. This, if we divide this side by inverse the Z, then that is called the admittance. Instead of impedance, that's called admittance. And R, if we inverse it, the R, that is called conductance. And if we inverse the reactance, that is called the susceptance of the system. Then we know that Z is equal to R plus J, and so the Y is also equal to G plus JB. And each one of these parameters, Z or Y, it is calculated by V and I. If we have V and I of the system, these two values, Z or Y, can be calculated. Similarly, for the zero sequence component of the system, Z0 is equal to R0 plus JX0. And inverse of Z0 is Y0 is equal to G0 plus JB0. These values can be calculated from the zero sequence voltage and zero sequence current of the system. And if you want to show in phasor diagram, we should tilt the reactive axis and active axis of the system, because we are discussing about the zero sequence components. This Y0, it is divided into its components of G0 on real axis, the vertical axis. Now we call this axis as a real axis, and this part as an reactance axis or imaginary axis. And the B0 is on imaginary axis. Now let's understand how these values are used to calculate the direction and how the system works by using the method of Y0 greater stage of G0 method, G0 measuring or B0 measuring. A deep similarity between these two methods are that in the first method, which we discussed, that zero sequence current threshold by cosine of phi and sine of phi measuring, or one of them, then there are many similarities are there. The same axis is there in this here. our graph is the same graph which we have used. There's just the parameters instead of I0, which we had in this direction before on the first method. Now we have the admittance vector, admittance phasor here. In this session, we gave just an introduction about the axis of this graph. And in the next session, we would discuss that how much should be this angle selected, what should be the parameters, what should be the phi correction and the direction measuring method, whether it should be G0 or it should be the P0. Now, according to our policies, we have V0 axis, and the active part of the admittance here, the admittance is there, the active part is on the voltage axis, and the reactive part is on imaginary axis. Here we select one axis to determine the direction, to know that the system will understand that which direction it should select as a forward and which direction should it select as a backward. We select one symmetrical axis. This is our symmetrical axis here, and we have not rotated it. That's why the phi correction is selected here in this example as a 0. And the part of the Y0, that part of the admittance, which is perpendicular to this symmetrical axis, that part is decisive for determining the direction. And we use this part that is perpendicular to the symmetrical axis. That part is used for the calculation in our system. Another thing is the polarized G0 or B0 threshold. This is the threshold that beyond this, for example, if our G0 be this much, then our system will not operate, it will not pick up. But when it goes beyond this value, beyond this axis, which is called the polarizing axis, polarizing value, it is programmable. We can define it, we can add, we can increase, we can decrease it. And this is just the tilt angle. There's alpha 1 and alpha 2 are the tilt angles for reducing the direction area or reduction direction area. If you want us to provide you more free sessions, learning sessions, please subscribe our channel and share the video with your friends.